Hey, hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's see today's problem, ancestors in binary tree. So what the problem is saying is, we'll be given a binary tree and a target. For example, a target is 7. Okay. What we want to do is we want to find the ancestors, right? The ancestors of the given target. So whatever is the target and whatever is the ancestor, right, in the path, right from the root. So we want to print that. Okay. So if you see the target here is 7. So what will be the ancestors here? It is going to be 4, 2, and 1. 4, 2, and 1. So whatever is the path right from the root till the parent, till the immediate parent of the target, all those are ancestors. So if you see the output here, it is 4, 2, 1. Okay. So that's what we want to return. Okay. So now how can we solve this problem? Okay. Now what we are going to do is basically we are going to do the traversal, right? The recursive traversal which we generally do. Okay. So here, okay, we are going to start with the root, right? Here we are going to start with the root node. Okay. So we'll check whether this value of the root node, if it is matching the target, okay, the given 7, for example. No, it is not. So we'll go to the left subtree. Okay. So here again, what we are going to do, is it matching? No, it's not matching, right? So we'll go to the left subtree. Is it matching with target? No, this 4 is not matching with the target. So we'll go to the left subtree. Is it matching the target value? Yes, it is matching, right? It is matching. So what we are going to do? We are going to return true here. That, okay, we have matched the target. Okay, we have matched the target. So here, again, what it is going to see? Okay, it is going to check. I have got true from my left subtree or from my left child. Okay, so what it is going to do? Okay, if it has got right, so that means it is one of the ancestors. So we'll have a result variable here, and we are going to add this particular node. Okay, with this particular node value we are going to add. Okay, then what are we going to do? We are going to simply return again back to 2. The control we are going to return back to true. So what is it is going to return? Definitely it is going to return true, saying that I have found the target in one of my child, in one of my as one of my children. Okay, here again 5, right? 5, it is going to return false because it does not have any target. So it is going to return false. Now at this juncture, we are going to check what are the left and right child returning, right? One is returning true, one is returning false. Okay, so we are going to do OR operation. That means true, right? True or false, right? It is going to give you what? It is going to give you true only. So yes, so this means that one of the children, one of the subtrees has the target value. So it is one of the ancestors, right? So it is going to add this value. So we are going to add this value to the resultant array or list, to the resultant array or list. Okay. Okay. So we'll return true here because we have found, right, in one of the children that there's a target match. So we are going to return true here, right? And again, in this, we'll go from this, we'll like basically traverse this subtree, and it is definitely going to return false at this, as it does not have the 7 value, right, as a target value match. So true, false again. It is true because one of the children, it indicates that one of the children has the target value. So it is going to add 1 to the resultant list. Okay. So in this way, we are going to solve the problem. Okay. In this way, we are going to solve the problem. So what is the time complexity here? It's O of n. So in the worst case, we may iterate all the nodes, and space complexity definitely is O of h, because we are going to, what we are going to take? We are going to use a stack, right? The stack, okay, which will by maximum, it will take O of the height of the tree, okay. And also definitely we are taking this resultant list, right, which will be again O of h space only. Okay, so this is the intuition behind solving the problem. Okay, before going to the code, I'll request you to subscribe to my channel, as a lot of effort goes in making this video. Okay, thank you so much. So let's code now. So first I'll show you the Java code followed by C++. Okay, so here what we're going to do, we are going to take our resultant list first. Okay, let's name it. Then we are going to call a helper function. We're going to pass this root, the target value, and the resultant list. Okay. So here is our helper function. Okay. It will return boolean. That is, it will return boolean. Let's see how it will return boolean. Node root, right? Then we have our target. Let's call it tar. Okay. And then we have our resultant list. Okay. So now what we are going to do? We are going to first check the base condition. If root equal to null, right? then simply we'll return false, right? We didn't find the target value here. Okay. Then another condition will be if root dot data equal to target now, right? Whatever is the target, then we have found our match, we have found the target value. So we are going to return true here, right? Now what we are going to do? We are going to have this, we are going to like call the tree to the left subtree first recursively, right? Root dot left you are going to call, and what are you going to pass? The target value and the resultant list as well, right? So here there is a left and right boolean, right? And what we're going to call here? The right subtree, right? So if we find in the left child or the right child, right? Left, if either of them is true, right? If either of them is true, that means it is one of the ancestors. This current root is one of the ancestors, right? If either the left child or right child returns true. So what you are simply going to do? Resultant dot add root dot data. So this current root, it is one of the ancestors, and we are going to simply return true here because it is one of the ancestors. So how? So for example, right here, so this was the case, right? 4, 7. So when we came here, it got matched. So what we did, we returned true here. From right, we returned true, right? So that's what we did here. When the root of data got matched, we returned true here. So so when so so when this left child of 4, right? It returned true. So left child of 4. So what is root here? Root is 4 and left child. It returned what? It returned true, right? And that is why we added 4 here, root dot data. Okay. If either if neither left or right child are true, so we'll simply return false here. So in this way, we'll get the solution, right? We'll simply return at the end result, return result. Okay. So this is a code. Let's compile. Let me submit it. So yeah, the test cases are being processed. Okay, they have processed successfully. Thanks for watching. I hope you've got the solution. Please subscribe to my channel and like the video. Let's quickly see the C++ code as well. Okay, so here is a C++ code. So what we are doing here is we are taking a resultant vector and then we are calling the helper function with target and result values passed, right? Then what we are checking is the base condition. If it is null pointer, then we simply return false. If there is a target match, return true. Then we are calling the left and right subtree recursively. And if either of them returns true, right? In their left and right subtrees, then simply what we're going to do, we are going to push back. We are going to push back the root of data into the resultant array, and then we'll return go to true, right? If neither of them are true, we are going to simply return false in this way. And finally, we're going to return the resultant array. So this is solution. Definitely, it will be accepted. Okay. Yeah. Thanks for watching. I hope you have got the solution. Have a happy, healthy, and a great day. Thank you so much.